supply and then dispatch them to your customers, which means nothing is left or lost in the process. That's the idea. So here the demand is zero, literally, for the warehouse. It's just a stop where you just divide things. So in this problem, usually what you have is you have individual cost for these routes. So if you are the manager of this process, what you want to do is you want to minimize the cost of meeting your customer's demands. So the objective function is minimize the total cost, subject to make sure you don't ship more than your supply, make sure you meet the demand, and make sure you don't leave anything in between. You don't lose your packages, right? So that's exactly what you have in problem 88. You are told that an oil company produces oils from two wells, well 1 and well number 2, okay? And that means what you have is this type of situation where you start with well 1 and well number 2. That's like the manufacturing plant. So you have W1 and W2 as your wells. And you're told that those wells can produce up to 150,000 and 200,000 each. So your supply here is 150,000 and 200,000. Okay, I will just use thousands as my unit here. Thousands of barrels.
One is 150, plan 2 is 200, or is it each one can do 150 or 200?
Well, well 1 can produce up to 150,
Oh, okay.
and well 2 can produce up to 200,000.
Okay.
All right? You are then told that it is possible to ship oil directly from the wells to the company's customers in LA and New York. So you have customers in LA and in New York, right? But alternatively, the company could transport oil to the ports of Mobile and Galveston and then ship it by tanker to New York and Los Angeles. So that means instead of going directly there, you have the option of transshipping those oils to, where is it?
Galveston's not a good port.
Mobile, well, we don't care.
It's subject
Okay,
to
so Mobile or Galveston. All right, so the option, these are like your warehouse. So you start from well number 1, you can send it to Mobile or Galveston, or send it to your customers in LA or New York. Those are the possible routes. Do the same thing for the second well. You can go to Mobile or Galveston or LA and New York. Those are possible routes here. And if you send them to the ports, then you can also send directly to these customers. So you look at all the possible routes here, but you know that these routes will cost you if you use them. You are also told that your customer in LA requires 160,000, and your customer in New York requires 140,000. So you want to meet that demand based on the supply that you have here. That's the idea here, idea in this problem. So this is your demand. You don't want to keep or lose things or keep them in a warehouse, because this way you're not going to make any profit from that. The cost of shipping 1,000 barrels between various ports are given in the file that I posted at Moodle. You have a file there. If you go to Moodle now, you'll see the file called P88, I think, P88 Excel. It's an Excel file that just gives you the cost of those.
You're going to be using it now, Professor?
Yes,
Okay.
we will need to use it. But before you go to that, let's look at how you formulate this. All right, so basically, what you need to do, what we need to do, is we need to build a model that looks like this. Your objective function is to minimize the total cost, total shipping cost, subject to, and the constraint is very simple, as I said before. You have to make sure that you don't ship more than you have, and that you meet the demand of your customers, and that you don't have anything left here, okay? Here what you have is what we are going to call your inflow, which basically means what goes in must go out, right? So, and this means in minus out is equal to 0. That's one way to ensure that we don't have anything left or lost in the process. So that means the constraint is the sum of the items shipped cannot exceed your supply, and your inflow must be equal to 0, and your sum of items shipped is equal to the demand. Here, the meaning of item shipped means arriving at the customer's site.
How, that doesn't work. How can you have items shipped less than or equal to supply if the warehouses have to equal 0 and supply has equal demand?
Basically, the item shipped means items leaving W1 and W2.
Yeah, you can't store them at the warehouse. The warehouse has to equal 0, so you can't exceed demand.
What we mean by equal 0 is what comes in must leave. In minus out is equal to 0. So if, let's say, a total of 500 arrives here, then you have to make sure that there are also 500 items
Yeah.
leaving there. So
Yeah,
that's
what I'm
the
saying
idea.
is the items shipped can't be less than, oh, well, if it's less than supply, then we're not,
There are 3 stages, right? I see the problem. There are 3 stages here. First stage is about the supply, right? Everything you send from these warehouse cannot exceed the supply. Cannot
Oh,
send more
okay,
than
yeah.
200.
I'm sorry.
All right? And in minus out must be equal to 0. And then the arriving here must be equal to 140 or 160. All right? So the idea is you're going to dispatch these to these places, but we need to know how many we are going to send through each channels here. That's the problem. We need to know how many we're going to send directly to New York, how many we're going to send to the warehouse first, so that we can even out our cost, minimize our cost, right? So that's the general form of our model. Okay, this is the verbal description or the just a general statement about your model. Now you have 2 choices. You can directly go to Excel, or you can build a mathematical model first, right? Usually, when you have this type of problem, building a mathematical model is the simpler route, because once you see the general form, this is similar to what we had for the problem we did last week. We had the general mathematical model, and then we translated into the actual Excel model. So in this case, the general approach is when you write the math model, what you do is you use this notation for the variables. Okay, variables are the amount you're going to ship through each channel. Okay, so the general form is x sub ij, and this is the amount that I'm going to ship through each channel, where I is the origin and j is the destination. So in order for that to work, most of the time what we do is we're going to number these nodes. Going to call this node as number 1, this is number 2, and this is 3, let's say this is 4, and then 5 and 6, right? So that means what you're going to say is if I write x1, 2, it means going from W1 to,
That one didn't work.
that's not working.
That went from supply to supply.
Yeah. So let's say x1, 4, that's this route, right? So that's what we mean by this notation, okay? So let's look at the data that we have then in order to build our math model, okay? So if you go to Moodle and download the file that you have there, you have the cost matrix for our problem. Let me just go there because it looks like I was logged out. All right. Oh, go to the doesn't really matter. Okay, this is what we want. This is how it looks like, right? This is our cost data. Basically, what it means is if I send from the first well to Mobile, it will cost me $10 per 1,000 barrels. And then where you see blank, it means you cannot use that channel, right? That makes our life much, much easier. So for the sake of notation, what I'm going to do is I'm going to number these places as 1, 2, 3, and 4, and 5, right? So just going to put 1 for well 1, 2 for well 2, 3, 4, 5, and 6, right? And 1, 2, 3, 4, 5, and 6. All right, so this is our data. Okay. So that means when I write the mathematical model, this is what we're going to see. Okay. I think we can. This is what we're going to see now. The objective function is to minimize the cost. We don't know which channel we're going to have, but what we're going to do is we're going to tell Excel to minimize, I don't like this, minimize the cost of all the shipping. I'm going to just take any route, all right? So the first route, if you look at the first row, we can send from well number 1 to the following destination, 3, 4, 5, 6. So X13, which costs $10 per unit. Unit here is the thousands of barrels. So when we get the answer, we get the amount in terms of thousands of barrels, and plus 13X 14 plus.
See, 1, 4, 2, 3, 4. Is that?
No.
1, 3?
1, 3 is for Mobile, 1, 4 is for Galveston, 1, 5 is to New York, and 1, 6 is to LA. You see, and then
It's true. Okay, stand straight away.
yeah, those routes. So the idea here is minimize the total cost. The cost could be going from well number 1 to Mobile, or well number 1 to Galveston. So when I use the word or, it means you have pluses in between, right? So 13x1 25 x1 5 and so on, all the way to, if you list all of these, the last route would be 6 5, which is LA to New York, right? So plus, and that cost $15 each. X.
Should we include
6,
the
5.
routes from,
So all
from
the
warehouse
cost
to
here.
warehouse? The routes from warehouse to warehouse? It's up there.
Yeah, all of these. I just skipped them because all you need to do is just write everything where you see numbers. But this is just to give you the general form, okay? So, and then, did I answer your question? Did I answer your question?
I have a question. What is the 65?
The 65 is, 6 is LA to New York. The last row, LA to New York. So basically what we do is wherever you see number, you have cost. Okay, but I skipped the numbers in between.
You mean
6 5, no, this one.
Oh, all right, okay.
Where you see blank, you don't have cost, so that means you don't include them in your total cost. And then subject to the first cost. If you remember what I wrote here, it says items shipped from the wells cannot exceed your total supply. So there are 2 wells here. So the possible items that you can ship from well number 1 are well 1 to Mobile, well 1 to Galveston, to New York, and LA. So that means the items that I ship from well number 1 to Mobile, so because I cannot ship from well 1 to well 1 and well 1 to well 2. It's blank here. When it's blank, you cannot use that route. So to Mobile plus x1 4 plus x1 5 plus x1 6 cannot exceed your supply. In this case, the supply is equal to, for well number 1, you have 150,000. So we say 150 here, right? And then from well 2, you have x23 plus x24, x25, and x26, less or equal to, what do you have? 200. And so that takes care of the supply, because we only have well 1 and well 2, right? And now, we take care of the second constraint here, which is, if you look at your note, it says the inflow must be equal to 0. What enters the first warehouse must be the same as the items that leave that warehouse. So we look at the following warehouses: Mobile first and then Galveston. So what arrives at Mobiles are those that are being sent to. So if you look at Mobile, this is the destination and this is the origin, because you see there, this is from to these places. So if I look at Mobile, here are the things that arrive at Mobile. Well 1 to Mobile, well 2 to Mobile, and Galveston to Mobile, right? That's what arrives at Mobile, right? So that means from well 1 to Mobile, that's number 3, so plus another shipment to Mobile is well 2 to Mobile, plus Galveston to Mobile, that's 4-3. So that's the inflow. The outflow is what we're going to subtract from that, minus anything that leaves Mobile. Anything that leaves Mobile are Mobile to Galveston, Mobile to New York, and Mobile to LA, right? So if we had the network, you would see things like this. This is Mobile, and then you have items that leave and items that arrive, right? You see channels that are entering and channels that going out of that node. So here you can easily figure that out. So living mobiles are those that are going to Galveston, so X34, okay, minus going to New York, 35, is that 35?
Yeah,
Okay, and 36. We say that
Equal zero.
equal to 0 because you cannot lose anything in the process. What leaves must be dispatched to other places. Quantity may be different from source to source. It's as if you bring in a truck, break everything up, and then dispatch them to different customers. That's the role of a warehouse. Do the same thing for the next warehouse, which is Galveston. You see that if you look at Galveston, you look at what arrives to Galveston. So 1, 2, 3 are those items we want. So that's X14 plus X24 plus X34 minus, look at what leaves Galveston. It's X43, and so minus X43,
X45 and
X45, and 46 must be equal to 0. We have 2 warehouses, so that means we must have 2 constraints for those 2 warehouses. Last thing is we need to meet our customers' demand, which means all the items arriving at New York must be equal to whatever they want there. Same for LA, right? So otherwise our customer won't be happy. So arriving at New York are those from the first well, X15, and then the second well, and then from Mobile, and from Galveston, and from LA. So that's 6.5. Must be equal to, what do they want? 140. And finally, arriving at LA, we need to meet the demand at that location. So that means if you look at the last column, that's what we want. So X16 plus 26 plus 36 plus X46 plus X56 must be equal to the demand there. The demand there is 160, must be equal to 160. And of course, we must indicate in our mathematical model that all these variables must be positive, right? So what's missing here is all, let me put it here. All x, y, j must be positive. That's the last line you need to put here. That's a formal mathematical model of that problem, okay? We started with a network, and then we have this mathematical model, and then we're going to translate it into Excel, which is going to be a quick process. So what we do is, you are going to basically indicate the cost. Well, the cost is already here, but you're going to essentially indicate here, using this notation, the following objective function. So you have the objective function, okay, just making sure that I have it here. And this is one way, just one way to solve it. There you go. So the variables that we have, okay, are, the book gives you a different way to solve this. This is a simpler way to solve it. The book gives you a fancier way to solve it using different functions such as if and other models. So what I'm going to do is I'm going to list all the variables that I have here. So I have, if you look at the model here, okay, you have x13, sorry, yeah. What you're going to do is you're going to list the variables where there is a cost, okay, and we're going to minimize it. So that's the the longer phase here. So you have x13, that will cost you something, x4, and then x15, x16, right? And then you look at the next well, okay? I don't have any x21, nor x22. I have x23, 24, 25, and 26. So I'm going to do that. x23, x23, and x24 and x26. Let's see if this will work.
What just happened? X23 what?
x23, 24, 25, and 26. Instead of typing it, I just dragged it to the right side. And then from Mobile, the only place where I see costs are between 4, 5, and 6. So that means the next variable would be x 4, 5, 4, x3, 4, and x3, 5, and x3, 6. So you just drag it all the way to x3, 6. Okay? And then from Galveston, you have 3, 5, and 6. So you can have x3, x4, thank you, 3, and then x4, 5, and 6. So let's just drag
You
it
said
here.
X43, X45, and X46?
Yes, yes. Basically, anywhere you see cost in that table, that's what we want. And then, if you look at the next cost, you have what you have, x5, 6 only,
And then X65.
and then x 6, 5. That's the only time we're going to do a lot of typing like this. X 5, 6. Thank you. All right. So,
Price?
and then what we're going to do is we're going to just look at this. Where you see the variable, it means the coefficient is equal to 1. Where the variable is not present, the coefficient is equal to 0. Right? So each row is made of these function. So each row is a constraint. So the first constraint is essentially the well number 1. So this is the well number 1. So what I see at well number 1 is everything that leaves well number 1 must be less or equal to 150. I cannot ship more than 150. And the route from well number 1 are 1, 3, 1, 4, 1, 5, and 1, 6. So what I do is I look at where those variables are, 1, 3, 1, 4, and 1, 5, and 1, 6. I'll put 1 under them. This is exactly as if I say x13 plus x14 plus x15 plus x16, because the coefficient is equal to 1. The rest is equal to 0. So you can just leave them blank. All right? And you indicate that it should be less or equal to, this doesn't really matter, it's just a notation, a reminder, remember what we did last week, is less than 150. Okay,
How do you do, never mind.
go ahead.
No, I see what you did.
Right, so it's less or equal to 150. Do the same thing for the next constraint, which is well number 2. Right, so for well number 2, we say that you can ship from 2, 3, 2, 4, 2, 5, and 2, 6. So 2, 3, 2, 4, 2, 5, and 6 are 2, 3, 4, 5, 6. Just put 1 under them, right, because that's the coefficient in the math model. So you're going to put 1, 1, 1, 1 here, right? If you see other numbers here, then you use the numbers you see in front of these variables. Because we don't have any other numbers here, it means the coefficient is 1, right? And we cannot ship more than 200,000, all right? And then the next constraint is about the inflows. Basically, so the inflow is at Mobile and then Galveston. All right, so what we have at Mobile is 1, 3, 2, 3, 4, 3. So wherever you see 3. So 1, 3, 2, 3, and 4, 3, minus, okay, minus 3, 4, 3, 5, 3, 6. That means there's a minus 1 in front of these, right? So instead of 1, you type minus 1. So minus 3, 4, 3, 5, and 3, 6. So I look where those numbers are. 3, 4 is here, so I type minus 1. 3, 5, and 3, 6 must be equal to 0. Okay, you need to hit enter after you type equal, otherwise Excel will think that you want to write a formula.
What did you do to get to making that right formula? Put an apostrophe or something?
Just type enter, right, instead of cursor. And then for Galveston we have, where we are, 1, 4, 2, 4, 3, 4. So 1, 4, 2, 4, 3, 4. Everything that ends with 4. So that's 1, 2, 3. Minus everything that starts with 4. Okay, so that's one way to look at it as well. So everything that starts with 4 is 4, 3, 4, 5, 4, 6. We okay? Equal to 0. And then the last two are our customers' demand. So if you look at here, everything that ends with 5 must be equal to 140. Everything that ends with 6 must be equal to 160. So I would just put 1 under those numbers. So for our customer in New York and LA, here's what's going to happen. Everything that ends with 5, so that's 1, 5, 2, 5, 3, 5, 4, 5, and 6, 5, must be equal to the demand, which is 140, right? And for our customer in LA, that's everything that ends with 6. So that means I'm going to look at 1, 6, 2, 6, 3, 6, 4, 6, 5, 6 must be equal to 160. All right? And so that's one thing. And our unit cost, we can also put the unit cost there in order to show these long. If you wrote everything here, you'd have a very, very long equation. But what we're going to do is we're going to take each of these numbers and put them under these variables. So what I mean by that is, if you look at what we have these first row going under everything that starts with 1, okay? And then for the second row, if you copy it, it should go under everything that starts with 2, right? And for Mobile, you do the same thing. You copy just the numbers under Mobile and then paste it under everything that starts with 3, okay? And then you do the same thing for the next one, which is Galveston. So you have 4, 3, and then the last two, which is 4, 5, and 4, 6. And then for LA, you have 15 and 15. You can just type that out. So that's okay.
So, copy.
Right, just copy paste so far. All right, so you can just improve it a little bit by just removing all the borders, but that's not necessary at this point. Indicate that these are monetary values, so I use the $sign, use the accounting format in that case. Now we can solve the problem. What we're going to do is, same as before, okay, so we're going to build the model. This is the actual model, okay, so that's why I put the word model under this usually. So what I'm going to do is I copy the name of the variables that I have, right, x1, x3, all the way to x6, 5. Just copy them. Reason why I copy them instead of typing them is if I made a typo, then Excel won't find which variable you're trying to solve. Okay, so copy it so that even if you had a typo somewhere, it will be consistent in what you're doing. All right, and just hold on. Need to remove this. There we go. No. And then reserve the cell under it because that's where you will see the solution. So I will just put my favorite bright yellow color there. And then, all right.
Can you zoom in for a second? What is it? You have all the,
Where? Where did I lose you? All right. So, and then after that, we're going to do the math. This math, we're going to change it into an equation here, okay? What I mean is, I'm going to actually enter this equation in the cell where, so this is the subject to, okay? Where I would say that if you look at what's happening here, what you did is really, you take this cell, multiply it by whatever quantity will be here, right, in order to verify whether it's less than 150, right, which means we're going to call our friend sum product, right, sum product of this row, whoops, and make sure you save your work as you, sum product of the first row and the reserved cells. Okay, select everything even if you see 0 there. Okay, because we have to match that with the length of our variables. Okay, and the highlighted variables, cells. But before you move away from that, just use the dollar signs for the areas where you have the blank cells.
How'd you do that again?
Just double click into the actual formula. Double click the actual formula and then type dollar into wherever you want to put it. So if you just double click here, like I do it now, you can just insert dollar sign. So when I click enter, it's going to be 0 now because we haven't shipped anything. All right? And then all you need to do is just drag that down, but before I do that, I usually copy the signs here so that I know where to stop, right? So I copy the signs, drag it down, okay, and I have everything there, right? And then copy the right-hand side. The right-hand side means this column. Right, just copy that. Way to copy that is just type plus and then point to that cell, right, like I currently have there, and then drag it down, okay. So one more step and now we're ready to use solver, okay. This part here is exactly what we have in the mathematical model. What's missing here is the minimum total cost. So you can put it anywhere. I'll just put it here so that it'll look as part of everything. And that total cost, if you look at your total cost, what you do is take numbers that you'll see here, multiply it by the unit cost. That's basically what you're going to do when you're going to compute your objective function. So the objective function is therefore a sum product of the following: your unit cost, wherever you put that, and your variable costs. And close the parentheses. There's no need for dollar sign because we do it once, only once, right? So it's just this times that gives you the minimum total cost. That's where solver is going to be directed to when you're going to compute your total cost. And it's best to use the dollar sign because it's basically the amount of money that you're going to spend. So I'll use that and just trying to be a little fancy here, just use a different color. It's not mandatory, but just, okay, so now we're ready to use Solver. What you do is, same as before, go to Data, click on Solver. It's going to be much easier than we did before, right? What you do is find the objective function. The objective function is here. That's why I colored it differently, because I know exactly where to go without thinking one more time. So I use that, and make sure you minimize everything. Okay, so where you know where the objective function is, indicate that it's a minimization. And then by changing the variable cells, which cells should I change?
So 27 through 32, C.
Which means the highlighted, right?
Oh,
So wherever you have the highlighted,
okay.
use that as variable cells. Basically, this is what we want Excel to basically put the answer. That's where the optimal solution will be. This is where we will know exactly how much how many items we're going to ship from through each channel. And then the constraints are three types. Remember, supply, inflow, and demand. So first constraint, if you go to the add constraint, is about the supply. The supply is the less or equals to, the first two then. So that's why I put these signs here. If you look at the signs, basically all I need to do is select the left side, indicate that it's less or equal to, and then indicate the right-hand side, which is 150, and the 200. Select everything. Okay?
We can do both at one time?
Yeah, you can do both at once because they are next to each other. But I have to stop here because there is a different sign here. The next part will be the rest because they are all equals, right? Saves a lot of time. So click Add, and then select where you start. You see the equal sign for the first time, all the way to where you see the last equal sign, right? I can do that because those signs are the same. Make sure you change this into equal, and then the right-hand side is wherever you have the right-hand side of that constraint. Okay? And practically speaking, we ended up with only two groups just because there are two types of signs, right? But in reality, there are three groups there. We say that, same as before, it's a simplex LP, linear program. And then once you click Solve, hopefully we'll have the answer, which we have. Okay, you can click on the answer and sensitivity. And you will see that there are two routes that you should use here. The rest, they are too expensive. This is the most optimal way to ship this item, which is 5.6 and 6.5, which basically means what? Just go straight to
From well one to
What do you have?
well one to
I have kids.
I think we're LA, only in New York.
Professor, I have a 0 and X65.
you have 0 for X65.
4,500, all zeros, and X56, 168.
And I have 2600 for the
2600.
minimum.
So basically, this is the optimal way. Just give me a second to check here. This is one way to solve it, and when you, let's just compare to the other model. If you go to your Moodle, okay, and look at this file. Okay, give me 2 seconds, and you'll see it. If you look at the file, please refresh your screen at Moodle. There is a file called Solution to Problem 88 using the textbook model. You will see exactly the same answer there, okay? In the book, they are using the if model. And basically, make sure you refresh your screen, please.
Yeah, I see that.
Takes a while for it to download.
Professor,
Yes.
I have the report show of visibility, not the answer.
You only have what?
I have like a visibility report instead of an answer and limited sensitivity.
Just give me a second.
Okay.
Are we downloading at the same time?
Yeah,
7,500.
Okay, this is, no,
Yeah.
sorry.
It says 7,500. Yeah, 7,500.
Supposed to be home 9:30.
Maybe I made a mistake as I talked too fast. We're able to open the file there.
You get it right.
Okay, here we are. Okay, here is the answer.
But you said this
According
one
to the
uses-
text, you start from well 1 and for some reason.
9:30?
Yeah, the answer is correct. 140 from well 1 to New York, 160 from well 2 to LA. That's what we have. If you open the
Something happened.
the files at Moodle, you'll see the answer exactly the same as what we did. Right, so what I want, the reason why I showed you, the cost is, what do you have for the cost?
We have 7,500, this is 7,500. He made a mistake, but he said
I think I made a mistake while I typed things here as I talk, but if you, I'm going to email this file to you, the one we developed quickly, so that you can fine tune it and see the errors. Maybe I mistyped something.
I'm not saving it. I didn't save it.
So I'm gonna save it and email it to you now. But the reason why I showed you that is because what you're going to get for the final is a problem that you can solve different ways. One way to solve the problem is using the transportation model. This is the problem you're gonna get. You are working for an investment firm, and you invest in foreign exchange currency. You have money in different countries, and then suddenly your boss told you to take the money out of those places, but you cannot bring them directly to the US. You have to move them to different places first in order to...
I can't participate in this process.
What's that? Not tax evasion, cost minimization. All right? Remember, this is a operations class or management class, so we minimize cost. We don't talk about tax. All right? So in order to bring money home, we move them to different places. So what your boss wants you to do is find the best way to bring the money home with the little cost possible, right? Which is exactly the same as we did here. The only thing is the cost might be different from what we have here, right? You'll see it in the problem. So that's why I want to throw that model to you.
What happened to the cost ramifications? Bring the money back.
Cost ramification could be
Tax.
Exchange rate.
exchange rate, you lose money,
Tax.
but tax is not part of the problem. Well, you can consider that in your model, but that would just complicate the model, because you pay tax anyway. It's a fixed cost. The variable cost is your currency exchange rate. All right, so
Fluctuation on, is it a day-to-day basis type of thing?
you'll see it.
Can
You'll see
you
it.
do us a favor and post it either tonight or tomorrow? Because some of us are gonna be home from work on a snow day tomorrow.
I will see if I can do it tomorrow afternoon. I think I can. Yeah. Yeah. It's, I need to activate it.
saying there is.
So,
Yeah, I'm uploading it, so, yeah, I'm uploading it. All right, so you will see, as I mentioned last time, the lecture for the last part are going to be at Moodle, right? Those are basically putting everything together and telling you how to use this for monitoring the performance of a company. That's the business analytics. All right, so I will see you on the 19th.